Today's going to be about Fluentd, how it fits into modern software landscapes and actually its relationship with more traditional IT. So let's get started. I'm going to talk a little bit about the book briefly, and then I'm going to talk about Fluentd, the modern log management landscape and log unification and some of the ideas behind it. And then we're going to go into a little demo just to show you how it works with a little bit of fun, and talk about some of the deployment options both in modern solutions and in in a microservice world, or it could be in a monolith world. So let's press on. So quick introduction to myself. Very quickly, apart from being the author to the current book, a unified login with Fluentd, which is currently a ME-app, early access program book, but well progressed, and more than half the book is now available. So hopefully you'll jump in early and have a look. But I'm also a technology evangelist for a UK company and a blogger, and I do a number of presentations around the world relating to monitoring and Java development and architectural design thinking. So when I'm not doing that, I'm helping run a developer meetup here in London, sponsored by Oracle. So we occasionally touch on Oracle products and technologies, but most importantly, a lot of it is about open source, because believe it or not, Oracle is going that way at the moment. Here's the book. So I hope you find today interesting, and it's enough to get you to go and pay for the book. As I say, I work for here in the UK. I work for a multinational called Capgemini as a consultancy. I won't say any more than that. Here are all the details if you're really interested. So let me talk a little bit about the book first, give you a flavour of what the book covers and how it might help you. So first off, whilst Fluentd is part of the CNCF family, it's perhaps not one of the best known members of the ecosystem. So we try and put Fluentd into a bit of context, a little bit of background of how it's become where it is, and how it's quite an important and useful asset to have in your portfolio of skills. And we can go from there. Then we get into the meat of the book. So we've got four substantial chapters that really go into the guts of how to use Fluentd. And by the end of these chapters, you'll be able to write basic Fluentd configs and understand the ins and outs and the nuances and the strengths and weaknesses of the tool. And then we really get into the power user stuff. So we look at performance and distributed models, supporting things like distributed computing, microservices. It can apply to IoT as well. And then for those special cases, or if you're developing a product that you want to make it easy for people to use with Fluentd, then how to build your own custom plugins. And you'll find that if you start digging into Fluentd that it's got a lot of plugins. There's in the order of 500, of which only 100 or so are probably core product. So it's a very active community out there. A lot of organizations now building plugins and offering them to make it easier to adopt, and you'll see some of the reasons why as we go through the book. And because we're dealing with logging, obviously we can't escape the fact that what Fluentd can do for us and help us with is only as good as the logs that are generated. So we're going to take a look at what we think are good logging practices, and certainly others in the industry would agree with quite a few of the findings, because I've validated them as it goes with a bit of research. And of course, one of the things that is important to making logging easy is a logging framework. If you're a Java developer, you'll probably come across Log4j or even the basic Java logging framework, but just about every language out there has some variation on the theme. So we will have a look at that in the book, talk about the frameworks, how they hang together when they're following sort of the more common patterns of dealing with it, and how you can integrate them into Fluentd in a more direct manner so you get better efficiency and performance out of it, and life gets easier with configuration. So let's have a quick look and have a view of the lay of the land and sort of some of the ideas that exist out there today now, because logging's moved on quite a bit. We've got system reliability concepts now very much a lot more embedded. The needs of microservices have driven logging thinking forwards as well. So the days of just doing standard out are long behind us. So we can characterize logging in 3 dimensions, or monitoring in 3 dimensions. The first being metrics. So this is largely numerical in nature, and you'll see things like memory usage, CPU usage are all classified as metrics. It's pure numbers. You can do straight arithmetic off it and things like that. Then we've got logs, which are pretty much textual and constructed in fairly structured forms. The payload may be JSON, or it may be just free text, and we'll see this being generated most often by applications, but the system infrastructure quite often these days will do that as well in the form of logs to SNMP and things like that. And then we've got traces. Traces is probably the newest of the family in becoming more pervasive and being used a lot more, and that's been driven by the fact that the world of microservices has driven the need for tracing a lot harder. Although if you're familiar with some of the enterprise service buses, Oracle SOA Suite is the one I know best, you'll actually recognize the idea of tracing, because it tags all of its logs with a transaction ID, or what's known as an ECID, and that's effectively a trace, so you can follow the transaction or activity through all the different components that your service bus is integrating. Same basic idea even in the microservice world. So we can take these 3 characteristics and superimpose them onto a platform or a complete solution stack. And as you look at the different layers, you'll see how we tend to use the different aspects, which is why if you talk to an infra person, they're more likely to talk about stats and memory usage and CPU usage and disk usage and maybe temperatures and details like that, network consumption. They really are looking at the raw numbers. And then, of course, if you're into virtualizing and containerization, you're going to be doing a mix of both. You're going to be looking at textual logs to an extent. So what's the container management and container orchestration doing? But also still looking at those consumption stats. We move up to the application space and we kind of swing the other way now. We've got tracing going on because we're looking at activity across time, potentially distributed as well across multiple services and multiple CPUs. A lot of logging still going on here, and some stats you're going to be logging usage information as well, but the stats are more likely to be about users or transactions and things like that than perhaps raw hardware based numbers. And we go up again, If you're into business activity monitoring and looking at what the business usage is and how is the business performing, you're going to be interested in traces. You're interested in transactions, how many transactions are dropped. If you're into online retail, then basket drops are a very, very important statistic to you. You're going to be looking at logs still, and you're still going to be taking some metrics as well. How many users are on your platform at any moment in time, measures of latency in the user experience and things like that. So as you can see, depending on where you are in the infrastructure or in the stack, you're going to be looking at all three different metrics to varying degrees, and interested in the data. Fluentd, as I say, focuses on the logs dimension of it, but and that's the blue one in this diagram, but you can capture your numerical data in there as well and extract it to get some meaning if you want, although sometimes that's not necessarily the best way to do it, but when you're stuck, it's an option. And of course, alongside it, we've got to deal with security and SIM and capacity and monitoring as well, and they're measured on all aspects along our infrastructure and solution space. So how do we use the logs? Well, it depends where you are and what you're doing in terms of the stack. If you're working across all the stack, as you might be in a DevOps scenario, then you'll have an interest in all of it. But traditionally, we all tend to focus in one area. I'm a apps developer, integrator style background, so I tend to look at apps logging and pay less interest into the server style metrics, until of course I think the server is just swamped. So yes, we look at the performance behavior. That might be just pure CPU. That could be slow queries in your database and things like that, and so on. Obviously, we need to do security in this day and age, and in the world of trust nothing, we need to be able to secure our environment, and security in depth. You need to know what's going on, who's doing what, when. Is there any layer in your application that's seeing abnormal levels of activity, indicating that your firewall perhaps is trying to fend off an attack? Is that affecting your user experience, and so on? But the bottom line is when we take all these feeds and bring them together, it's for one thing only, and that's for us to be able to understand how our solution is supporting the business or not, as the case may be. And the business will be quite prepared to pay for the time and effort and energy to go into monitoring and log management if it's delivering value. But if we're getting metrics or trying to trace things without a concrete justification, then you'll find the support for what you're doing will probably disappear sooner or later. So in the industry, we've seen complexity growing. 20 years ago, we only had single core CPUs. We might distribute a little bit. Quite often, applications were communicating through the database or shared files. And then we've seen it progress. Networking, particularly, has helped to drive the distribution of applications, and then we've had multi-cores, which means threading becomes far more effective rather than just simply context switching on a single core. And our applications and middleware and platform software have been able to exploit that, and we've got to extremely complicated potential demands. If you look at a classic node application without any help, trying to follow what the logs, what's happening in the logs, can be pretty difficult because it's context switching all the time, putting events down and reacting to the next active thing whilst it's waiting for some IO, rather than for spawning a thread and just letting that thread wait. So we've just seen this exponential growth in complexity, which has meant monitoring has become more complex. Therefore, we need more out of our tools to help us monitor. So Fluentd came along quite a few years ago now. It's actually about 10 years old, I think. But let's talk about what it can do and what it is. So it's a highly pluggable framework, unsurprisingly, in this day and age. And it takes inputs from a vast variety of components, from receiving TCP messages to looking at log files to SNMP traps to HTTP sockets, all sorts of things like that, and then it's able to take that information, gather it up, merge those sources together and push them out to different destinations. And those destinations might be things like Splunk, if you want to use Splunk for your security analytics. It could be pushing the data to Grafana and Prometheus to do time series analysis. And things like that, and then of course just chucking the data into things like Elasticsearch to do analysis in a sort of post-event world. And all of that, of course, you need to be able to format the log events to the different formats that the systems want to consume, and lay out the details to make it easy to search. If it's one long string, your querying is not going to be effective. But if you understand the source, then you can apply some semantic meaning. Take a classic web server log and then start breaking it up using an understanding of which web server it's from, and saying, okay, well, we know the first number of characters are the date, the next number of characters are the server, and then the last chunk is the message. So you can start dividing that up. So when you put it into your NoSQL or SQL database or anything like that, you can then start to extract the meaning more effectively, more efficiently, which is going to make your life a lot easier rather than trying to write complex regular expressions to search one big string and ignore parts of the message. You can store it, and of course as an exceptionally good framework for building your own extensions. You can characterize the flow, if you like, of monitoring information into a number of steps. You can look at the information source and capture whether that's a log file, SNMP traps, talking to the JVM, or the other, a Ruby engine, or Growl, or anything else for that matter. You can then, once you've captured that information, you obviously need to structure it and route it to the right place. Structure, as I say, is trying to get some of that meaning, and then you can get into the space of aggregation and analyzing the events. You might even want to filter out some of the events, do some simple counts. How many of these kinds of events have I had in the last hour? And that really all fits to Fluentd's sweet spot. What it doesn't do, but looks to other products to do to focus on, is to leverage them to give you the visualization and the notifications and alerting. There are a plethora of really good tools out there for doing these things, for data visualization and notification and alerting. So the community behind Fluentd have sort of taken a step back and said, do you know what, let's focus on one thing and do it really well, which is the collection, structuring, and extracting meaning from the logs, and then passing it through to something that can then do the processing downstream, such as visualization and notification. And actually our demo illustrates how we can do that in one of many ways. So You may well have heard, or most people, particularly those working in the sort of microservice world, will have heard of the ELK stack or ELK. So that's Elasticsearch, that's Logstash and Kibana together. And they fit into the capabilities this way. So you can see Logstash and its baby brother Beats is doing the log gathering. Then you have your Elasticsearch for doing your analytics. It's a data and analytics engine at the heart of it, and of course Kibana to then visualize it. And you might use Prometheus to try and generate time series based data as well. Compare that to what's sometimes referred to as the EFK stack, which is actually becoming more prevalent in the last sort of 18 months, and that uses Fluentd rather than Logstash, and Fluentbit, which is Fluentd's baby brother, and is a bit like Beats in so far as it's a very, very small footprint. So it's great for using an IoT and tiny devices, and its job is just to capture the data and push it out to its big brother, which you might run on a server to do a lot smarter processing of the log information before passing it on into the analytics and search world. So they're the two. So if you know the ELK stack, then you can see how Fluentd will fit in. In terms of differences, the key is that Fluentd has a bigger community behind it, and as a result it's gained a lot of traction in terms of community developed and third-party developed plugins, which means its adoption's become a lot easier. In terms of history, it's become part of the CNCF community, and as a result, through stack drivers, you can see it being incorporated into your Kubernetes-based environment to do your log capture. So any container that spits content out to system out, standard error, will probably end up finding its way through a Fluentd node to be processed into something a bit more meaningful. Compare that to Logstash. It's a slightly larger footprint, but not by vast amounts, but because Elastic have tried to keep a more of a commercial control on it, whilst it's the core of it's free still. The community hasn't developed to the same level of building a lot more plugins. So there's 100 to 200 plugins kicking around for Logstash against the 500 odd for Fluentd. That's not to say Logstash is not a good product. It's a different product, nicely integrated into the ELK stack, whereas Fluentd is a little bit more forgiving and more flexible, but it potentially needs a little bit more understanding, a little bit more work to get it to really sing with the components you choose to work with. The makeup of a log, so every log entry that's generated is given a structure, even at the most basic things. So the log structure goes into what's called the record, but Fluentd, every time it captures a log, will actually associate with it a timestamp of the moment it captures it and sees it, and a tag, and you can attribute the tags based on the source or the technology. And if you get into the details, and then the book explains it, you can start doing some very clever stuff like dynamically adjusting the tag based on what's going on. So you could make it a customer flag quite easily, and as a result you can do things like filtering and routing based on tags, and you can reset the timestamp. So if there's a bit of latency between the log file appearing and When you pick it up, you can reset your timestamp to be the time that the source system was reporting rather than the time you picked it up, and so on. So there's a lot of flexibility, but everything builds around this. You can tell Fluentd to treat the record as a JSON structure, which makes it very easy if it is a JSON structure to then navigate through it and start pulling bits of information out. And this comes back to this meaning. And you can actually add information into the record as well if you want. If you want to stop, if you're finding yourself having to do some derived values based on other attributes in the log, there's nothing stopping you actually saying that I'm going to insert the calculated value in there as well. So if you wanted to make life easier downstream by putting the difference between the timestamp of when you picked up the log versus when the system thought the transaction occurred, you could calculate the difference and put that as an attribute of X seconds or milliseconds into the record if you wanted to. So downstream, you've not got to do that. It makes life a lot easier rather than having to reprocess the event again. So it is a more of a declarative syntax than logstash. Logstash looks more like a traditional code with if conditions and things like that. Fluentd is a little bit more declarative, although there is a little bit of sequencing still important in terms of the log configuration, and that's explained in the book and how to make that not a problem and things like that when you get into really complex scenarios. But you can see here, this is a little bit of the demo we'll run shortly, where we've got some instructions to the system, and then we're saying we're going to take a source, that source being wherever the logs come from, and then you can create a series of operations that can occur on the logs. And in this case, you can see that we're going to look for an occurrence of a string in the message structure, and we're going to push it to standard out on the way through. And then if it complies with our filter, then we're going to actually push the message to Slack. And this is a little diagram just to help understand how Fluentd works. So it basically takes an input, tries to take it through a series of what Fluentd calls directives, and acts on those directives. And you can see on the right how that lays into the configuration. Okay, so let's have a look at my little demo. So just to bring this to life for you a little bit more. So I have a situation that I have several simulated apps generating app logs. I want to bring them together, and I'm going to apply some output to one of those streams before aggregating them together, and then I might want to run that in multiple servers. So if I'm scaling my environment, I might have multiple servers running the same requirement. Therefore, I want each server to have its own Fluentd, rather than trying to expose all the file systems in each of those servers to a common point and run remote access. So I just put the Fluentd node locally, let it work with the local file system. It's a lot more secure. You're not opening up firewalls or things like that into that node, other than allowing the traffic that's part of the application. And I'm going to forward that into effectively the idea of a central point, which could be running on a separate node. In the demo, we're going to talk about node 1 and node 2. So node 2 is my central point, and we're going to have a common pipeline that's going to filter out some of the log events Specifically, it's going to filter out any event that's not talking about a computer, and it's going to pump it to standard out, as you just saw in the fragment, and push it on the message onto Slack when it complies. So we'll see in Slack it popping away, telling me about when my simulated log feed is generating a message about computers. And you can see there it goes across the network as it happens. This is all running on my local machine here, because Fluentd is beautifully small in its footprint, so I can fire it all up on one machine without breaking sweat. But you can imagine this is in your network very easily, and this is it will be sending compressed HTTP based traffic across the network between the nodes. Okay, I'm going to drop out of this presentation and actually show you something living and breathing. So if I bring up my Windows shells, as you can see, I have run them a little bit earlier just to make sure that I haven't damaged my configuration. So I'm just going to shut the existing processes down. Right, so 4 screens, node 1 in the top right, node 2 in the top left, and then the 2 bottom shells are running a little tool that's been built. It's open source, that can take a log file and read it and play it back as if it was now in real time, which is a great way of looking at system logs and rerunning them to see what's going on and checking your Fluentd config and things like that, because it looks and behaves just like it's live, but you don't have to run your applications. Then as I say, we've got these 2 consoles with the nodes, and you'll see the Fluentd nodes chattering away on these screens and the log simulator. The log simulator as well, not only can it replay, it can actually generate logs in a structure of your choice, so that you can simulate config and just give it some raw data and tell it how to lay it out. So let's have a quick look in my IDE, and I can talk you through the configs. So here's my simulator, and you can see one of my simulators is going to create a message using a format of message. It's going to add an attribute called stream and call it basic file 2, and it's going to add a value called iter, short for iteration, so that as it loops through my simulation data, my simulation logs, it's going to tell me what iteration I'm on. And you can see I can parameterize the values, and I can give it things like thread information. I can create synthetic class path information as well if I'm not replaying a log that's already got that in it. So we have 2 setups, and as you can see, ever so slightly different. So rather than iter, I've got cycle, and I've got event, and I've got a source. And the paths slightly different and details like that. Right, but let's look at the all important Fluentd configurations. So this is node 1. As you can see, I've just annotated it a little bit. You can see I've defined a source here, which is going to be a flat file. I'm going to read 5 lines at a time, and every line that forms a full log will get a log event generated and a tag associated with it. And I've just said, look, give it the basic file as a tag, so we know the source of the event from the tag, and because you want to, when you're looking at logs, you want to track how far you are through it, so that if you want to tune your Fluentd config, you can stop it, restart it, and it'll carry on from where it left off, rather than necessarily going back to the start of the log and reading from the beginning again. And it copes with all sorts of interesting things like log rotation and things like that. I've told it can treat the payload as JSON because I've defined the structure in my config as a JSON log structure, but don't have to. You could actually parse it into a JSON structure if you want. And then I'm going to put it into a pipeline, which is a series of enclosed steps called the label pipeline. And that goes down here, and it then says, okay, I'm going to filter it. I'm going to use the record transformer. So there's a bit of debate over whether log entries should be changed or not, whether they should be mutable or immutable. Some will say, a log event should never be changed because you're changing the truth of what the system said at a moment in time. I've always taken the view that yes, you need a copy of the log event that's as the system represented it, but it doesn't stop you from adding information if that makes your life easier, as long as you know what's been added vis what is original. But in here I'm just going to grab it and manipulate it, getting the event, the message, creating an attribute in the log event called message, which was called event, and then I'm going to actually just blank the original event. So now my message is exactly the same as my original configuration. So if you look here, in here I've got message as my structure, and over here I've got it as event. By doing that transformation, I can then use the same parsing rule on that part of the payload to do more intelligent stuff. So, if your system's generating the same information but calling it different things, is a noddy little illustration of it aligning the two to make your next step a lot easier. So when you come to doing your analysis, your queries on the log event history are going to be an awful lot easier if the basic structures are similar. So if I come back here, I'm then going to do two things. I'm going to send the log to my local file, and I'm going to send the log event to my folder mechanism. And here's my folder, and I'm saying every 5 seconds take the cached log events and forward it on to my other node, which is, as you can see, on my local host on a different port. So if we look at the other configuration, which is this one here, you can see I'm now taking my source here is what's being forwarded to me, and I'm then going to go into my common pipeline, which is here, which does a filter looking for messages now because everything is in the same structure, and look for the references to computer or on computer, so that I'm not worrying about case, and I've just kept my pattern simple while I'm trying to say look for a capital C or a lower C. There's a little neat trick that Fluentd provides called a filter to standard out, which is effectively just like a printf style of event. It sends the content to the console. Then I have a match, and I am matching it to an output plugin called for Slack. And you can see I provide some details about how I wanted to display it in Slack, which channel in Slack. If you're familiar with Slack as a social medium, we'll see it in a minute. And before anybody gets any ideas, I'll be changing the key after this session, so I don't get spammed to death. Right. So that's my configuration. As you can see, it's pretty straightforward. It's not very complex for what we're trying to do. So let's start up my core node first, just so that we don't get any whinging going on from my source node. about not being able to contact the downstream. You can do some clever stuff as well with Fluentd when it's trying to communicate over the networks. You can tell it about a secondary output, so rather than just losing the message, it can go and talk to another destination, such as just write it to a local file as an interim. And what we have here now is Fluentd's just started up, and it's very quick, and it's analyzed the configuration, so we can do lots of things like actually build some fairly complex configuration by aggregating the content together, such that we can draw fragments of configuration files together. So if you've got a common piece of configuration, you can then include it, and it'll actually compile it effectively into the whole configuration file and show you what its final configuration is going to be on the console if you've got the right logging level set. You can see it's fired up and it's ready to go. So let's get the other node up and running. And there we go. You can see it's just spat out the setup. And it's just giving me a little nudge to say, okay, there's a little thing in here about the way you've configured this. Right, so that's my two configurations. So now down here, I am going to fire up my two simulators, and these are going to start churning out at a very rapid rate messages. So if we start them, and what you'll start seeing now is on node 1, the log events starting to generate. So over here it's just saying, okay, right, so in node 2's, no, it's going to node 1 what we're saying, but it's not putting system out. But over on here it is pumping to system out. Node 1 is going to the file. As you can see, it's putting standard out, and if I bring my my Slack session over, you can see now this is, there you go, there's another message coming in, and I'm using the tag that's being passed through to indicate the title of the Slack message. So it's saying, okay, so I've taken this from basic file 2, so we know through our configuration that means that I've taken it from my basic file to source, and it's saying, look, and the node I've kept added and carrying that through. So node 2 says, okay, look, here's a fact, and here's from another one, and you can see that it's aggregating up these messages because I'm batching them up every few seconds before sending it through. So you'll see a batch of messages, and it will keep doing that for as long as the data is being allowed to play. So whilst the messages aren't very exciting, you could very well see that you could take this kind of use case and say, okay, if I've got a significant error, or if I've recorded and detected a number of errors occurring over a time frame, I could then send a Slack message to whoever knows about that system and has the expertise to go and fix a problem. So it's a lot more proactive than having to run queries across a Elasticsearch or a NoSQL database to go and look for these events, and that could be happening a lot longer. So you now got a far more proactive model of processing going on here. Yes, you can you can get a lot cleverer than this. There are systems like PagerDuty, which has got its own plugin, for example, which will not just pump it to Slack, it will actually work out based on who's on duty for support and send it to the right person. But those dozen or so configuration attributes has got this notification going from several log files with slightly different formats, looking for specific occurrences of words with very little effort. So I'm going to put that to one side, and my simulators have finished because I only allowed them to cycle through the test data half a dozen or so times. You can see my processes are running. Now what I can do very quickly is, because I mentioned that the logs will write into file, you can see here's an appended log, and if I go into here, there you go. So you can see the basic file was being pushed to a log file, and there's the cycle number that I was adding dynamically. There's the source, the timestamp, and that's the tag that's been recorded. So rather simplistic perhaps, certainly in its current form not entirely practical, but it is, conveying very quickly, very easily the power of this technology, and hopefully you can see how it can be very flexible, and it doesn't take much to go. Actually, during development in a shared environment, you could filter out log events for your application via another microservice that's being tested in the same cluster and things like that. Extremely easy. Okay, so I've started to touch upon deployment models. Let me just flick back into the presentation content, and we'll go through these. Alright, as I say, fairly simplistic. I've not done anything like gone into a database and monitoring the database activities and looked at the database for what the recent slow queries, but you can do all of that and an awful lot more very, very, very easily. Okay, so modern apps scale, and we know very well about the Netflix and the Amazons of the world that go to super hyper scale, but even the smaller businesses need to be able to scale to multi-server setups, and therefore let's look at how Fluentd can be deployed. So here is a deployment model. This is a fairly common one. You'll note I've put into the diagram servers. There's nothing here that says you can't use Fluentd in a traditional server, maybe it's virtualized, it even maybe bare metal environment. And all you're doing is, as you saw in that demo, is you can gather up the logs from that node, or if you can mount file systems across multiple machines, you could collect logs that way. Although it's not the prettiest approach, but you can aggregate them up, and you can do things like failover and configure it to say, okay, right, here are my two nodes, this is my primary, here's my standby, and they can aggregate and filter out the events, doing the sort of thing I've just done with Slack by sending alerts in more real time to a monitoring or alerting service, as well as pumping it to an analytics platform where you're looking for trend and patterns of occurrence, which is what your SIEM models are likely to want, where you're looking to see if people keep signing in and out, or is one particular user seemingly failing to log in, which sounds like someone's trying to do a brute force password attack and things like that. So I could translate that very easily in thinking to a microservices containerized solution, using Kubernetes or OpenShift just as easily. OpenShift actually uses Fluentd under the hood as well, and you can see here now that it's just a case of I got pods in several worker nodes, and because it's a container, and ideally a container is only one application, You might want to reduce it to having just Fluent bits co-located with that application, or even drive it using a shared file system, or using the sidecar pattern, so it becomes a supporting service to several containers. You've got a raft of choices there to apply. I mentioned Prometheus and Kibana earlier. So yeah, Prometheus is a time series data store, and Kibana is a typical visualization engine associated with it. Fluentd can be used to send data to Prometheus very easily. So you could filter out messages and say, okay, these have got data elements in them that are good for and useful to present as a time series piece of data, and therefore just send that on to Prometheus to extract and process. You can reverse that flow as well, so you can actually take the data, it comes into the core Prometheus server, you do your data time series, and you also can push out the results of that time series activity either to the exporter or to the alert manager, to Fluentd, where the alert manager is saying, oh, okay, right, you've had more than 10 of these kinds of events in the last 5 minutes. We better put it back into the event logs. Something untoward has occurred. So the benefit of that approach means that you can start looking at one place for the truth when you're monitoring, and then go, okay, so we know that our metrics-based monitoring activities are detected that we've got an excess of certain things happening. A CPU is too high, the I/O demand is getting too high, getting close to limits and things like that. And you can see in the logs that's occurred. That allows you to then go back to the Grafana, for example, and view the time series data for that moment in time to get a visual representation of the state of your infrastructure, for example. Or it could be actually monitoring data and generating numeric analysis-based information around your business. So if it's counting the number of successful sales or dropped baskets in a time period, again you can log that, and then you can go back and look at what's going on and see what else was happening in your time series based data. It's certainly not a case of you do Prometheus Grafana or you do Fluentd. They work together very well, and you, as I said at the outset, you will probably want to leverage those different technologies for those different views and different perspectives, numerical logs and business perspectives. But you can certainly force the issue if you haven't got that full toolkit. Fluentd itself is very scalable. It is built on Ruby, so unless you're using a particular version of Ruby, it does have a global thread locking mechanism. So what happens is that Fluentd is spawns itself into multiple CPU processes, so those thread locks do not get in the way. So you start out, if you're using a very vanilla setup like I was just now, you'll have a supervisor process and one worker. Supervisor is basically there, and it will answer any queries about its status. So you can ask Fluentd to report on itself and things like that. And then the worker process will actually execute your Fluentd config. You can target your particular Fluentd activities, so you can target a source to a particular worker node. So we can add worker nodes and say, okay, right, worker 1's going to deal with these sources, worker 1 and 2 can deal with another source, and worker 3 maybe deal with a fourth or a fifth source. And that way you can say, okay, this is how I'm going to divide the labor. But you do need to be aware of what it means to be multi-process centric. For example, now trying to log to a file when you've got two separate processes right into the same file can get very chaotic. So you best off not doing that. Keep it as one worker writing to one file. But you can, in the configuration, say, okay, right, my log files are going to be log files based on per worker now, so there isn't that collision. So a lot of these common problems have all been thought through for you in Fluentd, and there are some clear, good answers to solving them. You just need to know that you've got to watch for the problem, and then you'll be able to find the answer quite easily. So this is drawn from a compound of several use cases that I've worked on over the last couple of years, and you can see that we've got multiple destinations, we've got multiple backends, so we've got Kubernetes and we've got just virtualized apps, and we're also having to deal with cloud deployments. And one of the things that was decided upon was that we'll go with the CNCF solution, which means that we can run it anywhere, whether it's in AWS or Google or Oracle Cloud or Azure. Doesn't matter, it will still run, and we can route these things through to the right things. And you can see at the bottom I've actually overlaid that sequence of events to show which components are doing what. So you can see I've got the information capture at the left, then I've got the structure and the routes, the core Fluentd nodes, then I've got aggregate and analyze, and that job is being done by Prometheus and Elasticsearch, and then I'm visualizing with Kibana off Prometheus, and Grafana as well for a little bit of that work, and I'm using Jira for tickets. So if I have an exception, a fatal exception generated, then I could create a Jira ticket for that. If it's less critical, lower consequence, maybe just a Slack message, or just put something in somebody's email and configure it so I don't swamp the email either. So that's a composite of several use cases, and you can see we've got the tracing here as well. So we're still using, because we've got microservices, the tracing becomes a lot more critical in that context. So we are using Jaeger, which is another solution out of the CNCF portfolio that supports the collection and sorting and sequencing of trace ID, so I can then see how a particular event is rippled through lots of different microservices. Even if that means passing through a Kafka topic and things like that, I can still filter it out and track what's going on for a single thread. So there you go. One of the challenges that we've experienced, or questions that we've had to deal with, is why should I use Fluentd when my cloud provides these capabilities? The answer is not so much about which technology is right, it's about your circumstances. The irony is Google, AWS and Oracle all use parts of Fluentd under the hood to provide their cloud monitoring capabilities. But do I use that, or do I use the original Fluentd? Well, the guidance that we tend to take is well, are you going to be distributed across multiple clouds? An environment's on-prem if you've got hybrid deployments. you might want to actually use a common technology across all environments, because it means you don't have to learn how to do the same thing in 3 or 4 different tools, or at least 3 or 4 different UIs. If you've got common rules, it's very easy to then apply them in all contexts. Is cost-free lock-in? I can't remember the pricing costs for AWS. It's been a little while, but I've been working with a lot of Oracle Cloud and looking at their new capabilities in this space, and it actually works out that the cost of running their monitoring solution is purely the cost of storage for your log events. Whereas if I do it for Fluentd, then I am actually having to pay for a bit of storage plus a bit of CPU. So if I was doing an Oracle Cloud dedicated answer, then maybe I just want to use that the Oracle Cloud solution. But if I'm trying to do a hybrid, then I'd probably start to swing back towards Fluentd, because it's the same tool in both environments. So it's one way of solving my common problems, and my ops team, if they're separate from the development team, have a consistent skill that will be understood and easy to tune and get the most of it out of it in each environment. So it's about what your needs are, not about the technology per se, because actually under the hood it is quite often the same technology driving it. And that's really it for tonight. It gives you a bit of a flavour of the sort of things that we've looked at in the book. You've seen Fluentd in action. So hopefully that will be a great help. Let's have a quick look at the chat, see if we've got any questions there at the moment. It doesn't look like it, but as you can see, that's me. My social contacts are all there, so feel free to ping me a question, or take a look at the book. Otherwise, I wish you a good night, good morning, or good day, depending on where you are in the world. Thank you.